con, at least you could watch this one. Or never watch it again, I guess, in the supper. Yeah. Okay.
This is from what to what equals, Steve?
From the center to the vertices, which is the same letter and the same thing in the ellipse. The big difference is the foci is actually farther away from the center than the vertices. Compared to the ellipse, the vertices are the farther away one. So that changes our equations a little bit. You'll see how that looks.
A lot of equations you want to spend.
There's a lot of equations. The foci is this point, the foci, and A is the distance between the center and the foci.
First of all,
Yeah.
there war.
War? Wall or war?
War.
War, like a fight?
The fast.
There's so many to choose from.
Yeah.
There's like 7, right?
I mean, there's hundreds. Yeah.
I like Asian War.
No, I don't. Civil War. I like Avengers Civil War. Yeah, let's go.
Personally, I'm a bigger fan.
No, actually, I like the DC one. What is it? Age of Apocalypse. That one is a good war.
I think the World Wars are pretty fun.
World Wars. It's so good. Everyone's involved.
This is the 30 years.
DC shows.
You gotta. The animated series is where it's at. Actually, that's why they actually
I
show.
love anime.
Don't wrong with that. This is not the 30 years.
I'm not everyone.
Exactly.
Sorry, not sorry. I'm translating the Bible from Latin into German.
That's how it works. Though. What up? Hey, hey, hey. So, I'm just gonna move on. One more thing. So you notice here, I didn't include anything with a B because there's no real vertical or a minor vertex in this case, but it is involved in the actual creation of it. Again, we are okay with just estimates. I was answering that question. If you get the estimate correctly and when you graph it, it's fine. But I do want to show where the B is involved. So I said the distance from the foci is A, but you have this, what we'll call the minor axis, which is over here. I'll just make a dotted line. And you have your major, which is like here, or your vertices like here. If you were to make this a box, again, this is just a side fact. The distance from here to this imaginary point that does not anything to do with the graphing, all it does, it makes an asymptote with the little box. It should be in the corner. I should do it more like this. There you go. So then, so this B value doesn't actually show up in the graphing of it. Guys, the B value does not show up in the, I'm asking you to be quiet, guys. This B value does not actually show up in the graphing of it, nor is it like in the traditional sense, like this is points that we actually find and use. This B is not used as a point. It's not a very particular point, but that minor vertex, and you'll see in quotations in the notes in the next page in the quotes, that helps you find the asymptotes. And we're going to use the formula very particular for that, okay? So let's scroll down. Everyone got this down? You should. Yeah, at least the left one down. Yeah, you'll see it when it's used.
I see you play some sort of console game as a maybe doing testing times.
A console gaming? No, I'm a PC gamer now.
You PC gamer?
Now I'm a PC gamer.
He's when? What happened
This summer.
Ah.
I still have my
Well, yeah, like what games play?
I'll answer that when I'm not teaching. No,
We don't
I haven't wanted to play YouTube.
I
I'll talk about it after. I'm going. What's up?
Yeah, you play Warcraft.
Wait. What?
You play with Warcraft, Overwatch?
Never played with Warcraft, but I know he does play Overwatch. Does he still play Overwatch? I thought he quit after Bridget release or something like that. Anyway, so here's your next table. Everyone look up the table here.
Your table.
So, hey, stop talking. Center is still the same as always. What's the center?
HK.
Good, HK.
Yeah.
A lot of it is reused, but it's new. HK, horizontal, vertical. Oh, actually, I should point out. For the vertical and horizontal, the difference is, like the ellipse, the A is always going to be with the major vertex. So the A will always be in front. But make sure since the A is in front, it has to be minus the second one. Before, if you swapped A and B, it didn't matter because it was a plus sign. Here, it really matters. Make sure A minus B. So make sure it's like that. This is very huge. So,
Yeah, it's standing to my feet. And you guys put it this way. Yeah, bro.
guys, there's half the class and you're still making all the noise. Stop talking.
That's 15 seconds to read.
Yeah, no. Well, if you want to read.
Does it say Bertha?
Big
What?
Bertha? So vertices, same thing, the vertices, except this time we only have the major vertice. We said the distance from the vertice to the center is A. So if it's horizontal, are you adding to the H or are you adding to the K?
The K.
H.
H, because you're going sideways. So this one is H plus A, comma K. And this one, because it's the vertical one, you're going up and down.
K plus A, comma, H. Yeah.
Make sure in the right order though.
Oh,
H, comma, K plus A.
maybe not really at all.
It's okay.
So why is this one not plus or minus?
One is just not, it should be plus or minus actually, yeah. Because you're going up and you're going down.
Nah, shut up, Mitchell. Thank you, Bill. You're welcome.
Plus, minus, A, plus, minus.
You don't have a full name.
Should be good. All right, the foci. The foci is also on the major axis, so it's gonna follow the same concept. It's just, instead of A, what's the letter we're gonna add or subtract?
P.
P? There's not even P in the whole equation. C.
There's not even a C in the whole equation. You can't tell me C is not a bad guess.
I already talked about it when I had the picture of the thing, that the C is the distance between.
Great day.
Right. Now, what's very different, just remember, in the ellipse, the C was bigger than A, or wait, was it?
The A is bigger than C now.
Yeah, the other way around. No, A was bigger than C before. Now, C is bigger than A.
Vertical?
Now, this one I would say is probably the most difficult formula to remember because it's the most unique. This one is the asymptote, which is that diagonal line I was trying to show you earlier with the box. So that diagonal line is Y equals K plus or minus B over A, X minus H. Yeah, I told you, this is the most awkward one because it's very unique. The bottom, the only difference. No, you would think it would be Y minus K. No, the difference is it's gonna be A over B, X minus H. So that's the actual difference. You would think it's Y minus K, but it's actually A over B.
You really want us to memorize those?
Yeah, I was about to say.
What do you mean? The center is like a freebie. Vertices and foci are freebie. This is the same one as the previous one, just with a minus sign. Like you gotta cut it in half. You gotta condense them in your mind. Don't think of it as 1,000 different ones. You gotta.
It's a double. Full hard drive.
All right.
Putting it up with a lot.
Copy this down because I need to scroll down and I can't keep the text.
I have it in my copy.
Did you build yourself a new PC over the summer? Yeah, I was on.
No, I got a really big nerd to build it for me actually.
That's why I haven't built one either.
Yeah.
Pre-builts are cheaper. I actually like that.
Are they cheaper than a full on building?
Right now, the silicon chip sorted. So
Okay.
now all CPUs and GPUs, processors are skyrocketed.
Ah, okay. So pre-builds are now cheaper.
Yeah.
For
Because they get it for cheaper.
that. Yeah.
They get it for retail and then you pay it over.
They buy it. No, they get it for not retail. They get it for what is it called? Not supply.
No, but they don't supply because the video they don't want to supply.
Yeah.
So like, hey, we have a stock like that. You can buy it at
Bulk.
cost before we sell it to everybody else, or we're not giving you supply.
Oh, okay. All right. I'm going to the next page. Anyone still copying?
Yeah.
All right. Shh. I already talked about this. Just to make sure you write it down. A is the major vertices. B's are the minor. Stop talking. A is the distance from the major vertices. B is the distance from the minor vertices. Foci. Notice the difference here. In the ellipse, it was minus. Here it's a straight Pythagorean theorem. A squared plus B squared. So make sure you know it's A squared plus B squared. And then the major axis length. The major axis is just from, so the major axis length. Remember, if it's the distance from the center to the major vertice, A, so you're just gonna do 2A. Because it's from one side and then the other side. You just add them together.
Oh, I got you.
Gotcha.
Minor vertices.
Now, again, minor vertices, because they're not actually applied, like in the ellipse, they're actually like the top and the bottom of the oval. In this case, it only makes the asymptote. That's why it only shows up in the asymptote thing, and it shows up in the original equation, but you don't actually graph this part with the B. You don't actually graph the B.
We didn't extend our test. I would.
I didn't extend your test. What are you talking
No,
about?
we extended to the 20th.
Okay, sure.
It was supposed to be this next week.
You're acting like you're not, like I wouldn't fail either way.
So now that we're done, no.
Oh, I'm on the last, I'm on major.
Dude, it's major axis equals 2A.
Yeah.
Yes,
Yeah, well, like.
but, okay. Okay.
Brandon.
So let's talk about this one. We're gonna find the center, the vertices, the foci, and the asymptotes, then graph it. All right, guys.
These are the times I wish you were not.
What? You mean you were, you switched you wasn't your cousin?
Stop
Wait, what?
talking.
Very mean, actually.
David.
Thanks,
David.
Sorry.
All right, so we're gonna find everything here. Just remember our original equation, if you don't have it already written down, is x minus h squared over a squared. Oh, and we know x is in the front because it's the positive one versus y should be the second one or the b because it's b over here. Oh, I guess another concept. Usually our a squared, b squared in the ellipse was decided on which one's the largest. That's not necessarily true anymore. It's going to be which one's positive and which one's negative. So a squared is always with the positive one and b will always be with the negative one. It's always a minus b.
It's not the same equation.
Hmm?
It's not the same equation at all. Just the minus.
Yes, but how you identify your a and b, just make sure it's not the bigger or smaller.
Um,
Because if you thought it was an ellipse, you would think 9 is
we
a.
can fit this all on.
So let's figure out what a is, what b is very quickly. If a squared equals 4, a equals 2, you can say plus or minus, doesn't matter. If b squared equals 9, b equals 3, plus or minus.
Are you have to write plus or minus when you were?
You don't have to actually write it. I'm just pointing out you are going left and right. So plus or minus is not invalid. All right. Okay. Let's see. So we got A, we got B. What is my H and K? I don't have anything subtracting it, so it must be 0, 0. So my center is 0, 0 because I'm not adding or subtracting anything from H and YX or H and K. Now my vertices goes along the major axis. So the vertices, you're adding 2. So it's going to be, since X is the major one, we're going left and right. So your vertices you're going to add and subtract 2 from the X value because it's the major one is horizontal. So it's going to be 2, 0 and negative 2, 0. I'm adding subtracting from the center. The foci, you're also adding and subtracting from the center in the same direction. So if the case is 3, it's going to be 3, 0 and negative 3, 0.
3, 0, why is it not like 0, 3?
Let's graph this so far and then we'll see why. So let's graph this. So first the center is 0, 0, right at the origin, makes it easy. The vertices is 2, 0, negative 2, 0. So 1, 2 over here, 1, 2 over here. And the foci is 3, 0. So 1, 2, 3, 1, 2, 3. The reason why it's 3, 0 versus 0, 3 is the vertices and the foci is all on the same line, the same horizontal line or the same, you could say, axis.
So it doesn't matter if you get that from like the quote unquote y value, because in the other ones, like the b was on the y axis.
It would be different if it was, yes, you're right. It would be different if it's that, but this b, oh shoot, actually, you made a good point. So b is the y-axis, right? I shouldn't be using b. What letter should I actually be using?
C.
C. So let me fix this. My fault. Good catch. So this should be C. So I need to find the C. Luckily, I have a formula for the foci. For when it's this shape, it's going to be a squared plus b squared.
How do I get image this? Like how?
I'll show you in a second.
You love the Pythagorean theorem.
Actually, I can't.
I use it on
So this is square root of 13.
Wait, what?
Plus or minus.
Why don't we just use the Pythagorean theorem? We all started laughing. She goes to the next slide and it said Pythagorean. Oh, that was pretty, yeah, that's not funny.
So then this is going to be 13 is between 9 and 16. So you know it's between 3 and 4. So we'll say something like 3.5.
Is that making a joke or is that just like? We're just making a joke like, yeah, well, Pythagorean theorem. Yeah, because of prior, I used Pythagorean theorem and then I got the random answer.
So the foci should actually be 3.5, 0 and negative 3.5, 0.
Yeah.
Okay, so we have center, vertices, and foci. These are the three things. What we're going to do now is find the asymptote, which is very particular. So the asymptote, this uses C, by the way, I should point that out. So we're going to find the asymptote. This is a horizontal one, so it's going to be A over B in this case. Or I'm sorry, B over A. So Y equals K. I'll do this in a different color. Y equals K plus or minus B over A, X minus H. So let's just plug in everything we know. Y equals my K value, which is 0, plus or minus B over A. My B value is 3 over 2. It's already plus or minus, so you don't have to put the plus or minus.
Well, which one to use, plus or minus?
It goes
both
both ways, so it's going to be plus or minus. So then parentheses, X minus 0. Let's clean this up a little bit. Y equals 3 over 2X. Wait a second, what form is this in?
Y is X plus B.
Good, this is slope intercept form, where your intercept is 0 and your slope is 3 over 2. If you don't remember how to graph slopes, it's rise over run. So 1, 2, 3 up, 2 to the right. 1, 2, 3 up, 2 to the right. And you do it the other way. 1, 2, 3 up, 2 to the left. 1,
Do we still have the center?
2 to the left. What is your question?
Why is it that when X is over A, that it's a y squared parabola? Why it's y squared parabolas as opposed to x squared parabolas?
Why is it
No,
X?
y squared parabolas being horizontal.
So I'm sorry, ask that question.
Like, why is it when X is over A, it's horizontal?
That's the X axis.
How it is.
I'm trying to think that. I just want to make sure I didn't mess up. Let me think. So the reason is if this is the major one, this is the major axis, right? The major axis actually dictates what is the orientation of it. And says X goes along with horizontal distance, then if X happens to be the major, the whole thing is going to be major. Just because it's the more larger or the more powerful, depending on how you want to think of it, axis.
Wait. That cleared up.
So we have these diagonals here. I'll just put dotted lines.
And now we should go from the vertices outwards without touching the asymptotes. So just like push.
Perfect. Yeah, get close to it. Some might say a limit to it. You'll learn that next chapter. So anyway, so we have our purple. Remember, the purple is our actual vertices. The foci is inside the hyperbole. So we go hyperbolas. So you make your U shape go along the asymptote. Of course, you could do much better than me and make it more smoother, but basically that's how you graph it.
I lost points last year for circles and parabolas are too zigzag.
Two zigzag.
Yeah,
Yeah,
I
we
do
lose
straight
points in
lines
this
next
class.
points.
Well, we lose points in this class for choosing that.
Zigzag? What would be zigzag?
No, like I'm saying, you understand where we're
Say,
going,
Rosie.
at?
If all of this is correct and it matches what you said, you'll get a point for the graph, even if you made a mistake
But
here.
like, for example, like yours is fine, but like I was doing my thing and it was just a little bit messy, but you understand where I was.
As long as I can see the pieces, I'm fine.
Let's say you make like a V instead of a C shape.
That's what
Oh, that doesn't.
that's basically what happened. Mine was too square, not round enough.
It's kind of hard to make a V shape though, because with the asymptotes, you know you're getting close to that.
Well, what I do,
But like parabolas, I understand. I make V shapes also.
Straight line going the closest asymptote, then a straight line along the asymptote basically was the issue. It's just
So as an example, you would do like this.
sort of, yeah.
That's a little aggressive. I wouldn't take points off, but I would say something about it.
It happened with circles as well. I do also a square diamond. But I
You should at least try to make it round.
I think connecting the dots.
Uh-huh.
There'll be a slight curvature, but like straight.
All right. I'm ready to delete this. Everyone got this down? Brandon, you got it down?
I got you on that.
Okay.
Yeah.
What's up? Cool. What's up, Anna? Yeah.
Yes, thank you.
I would like you to do this by yourself, but before we do it by ourselves, what do we need to do? What's the problem with this?
This is the wrong format. Yeah.
Yeah, we got to make it so it's clean. We needed to make it look like.
I think the first step should be divided by 16. Because
I know.
an aspect A value.
Brandon.
What's up?
I think divide by 16 is the first step to an aspect A value, B value.
It's getting close.
What do you think?
Why B value?
I don't know, where's the minus go? Minus goes in between the two, X and the right.
Well, we want to complete the square, right?
We'll get negative X.
So, I got you. Hold on. All right, first, we want to complete the square so we can make it nicer. Now for the X, we're going to rewrite this a little bit. So 16y squared plus 64y minus X squared equals 0. Brandon, stop talking. So here in this situation, the X is clearly going to be negative, which means our Y is going to be our major axis. But the X is already by itself, so we don't really need to complete the square for the X squared. We're happy with that. But the left side, the Y, is not by itself, so I got to deal with it. First thing I'm going to do is factor out 16 to make it a little easier. So Y squared plus 4Y minus X squared plus 0, or equals 0, my bad. Next thing, I'm gonna have to add a C value. Now, whatever C value I add here, so if I add a C value in here, I'm gonna add 16 times that C value because there's 16 outside. You have to make it balanced. So what's in there is gonna technically 16 would distribute to it. So we're going to do C value divided. So if you don't remember, it's B over 2 squared. So B is 4. 4 over 2 is 2. 2 squared is 4. So it's going to be 16 y squared plus 4y plus 4 minus x squared equals what's over here, 16 times what we found the C to be 4. This will be 64. Is it ironic that it was 64 again? That's not what always happens. So because this is now a perfect square trinomial, I can factor it out a little bit better. This is going to be y plus 2 squared minus x squared equals 64. But I need my equation to equal what at the end? 1. So what I'm going to divide everything by? 64. Good. So everything is going to get divided by 64. Now you're ready to start your question. Y plus 2 over 4 minus x squared over 64 equals 1. So everyone try to finish it off. Now you could actually start the question with graphing.
Is the A value always the one on the left, or is it always the one on the right?
Always the positive, which is you usually put on the left. The one that's negative is the B value.
This is C.
B
Oh,
value. C value, use the Pythagorean theorem. Or, yeah.
You go back to the other one, to show how, why is the Pythagorean theorem?
I'll do it here while everyone works. So we talked about it. You have this weird shape, right?
You have square in the middle, no?
You have the square in the middle, right? Well, you want to find the vertices, right, or the axis of symmetry. You have to make a diagonal line from the center to the corner of the square. We already decided that this is A. We decided that up vertically is B.
Oh, so we're talking the triangle,
So
basically.
you're finding this diagonal, which is,
Yeah.
that's why it's a Pythagorean theorem. Or,
If it wasn't A, B, and C as variables, you wouldn't have known it's a.
you wouldn't think of it like that, if you didn't realize it. Because when you deal with something like, when we do like sine and cosine, right? Like the trigonometry is x squared plus y squared equals r squared. Some people don't realize that's the Pythagorean theorem, so.
Yeah.
They usually teach a triangle first anyway, so.
What did you apply for the square root of C?
What's up?
What's the approximation of the square root of C?
What do you got? 8 plus 68. It's just a little bit above 8.
I did 8.2.
8.2 is fine.
No, you have, split it up.
It's 64 plus 4.
64 plus 4. Yeah.
68. Yeah. It's already squared on the bottom, so you don't have to actually square it again. Yeah.
No.
If you want to be more accurate, you make it a fraction.
4.4. Yeah, this square. It's very accurate. You don't find this.
No.
68 even, you take 4 out. You take 8 out.
Yeah. 68 is a little bit more than 64. So you know it has to be a little bit more than 8.
But it's 4 more, meaning it's around 2.
So
You're telling me 10 squared?
No, what I'm saying is, watch me.
8.2 squared might be above 64.
you'll finish this tomorrow. Do we have class tomorrow? Or is that even?
Yes.
We'll do this Monday.
It's 8.25.
Oh, I'm so sorry, I was 0.05 off.
Rounding technically, yeah, you move it up, but it doesn't matter. I got it. It's an approximation, and you don't need to actually get the hard number. No problem, no problem.
Can I talk to you? No.
You could.